So now we're going to look at how to solve a differential equation that is a differential system that's non-homogeneous. So something that looks like this. Now, if you remember back when we were doing stuff at the very beginning of the course and we looked at things like x prime plus px equals q, first order linear equation, the solution was to find an integrating factor by doing e to the integral of p. And then if you multiply the equation across by that, you end up with q times this integrating factor. And then you integrate both sides, and then you have mu x equals this. So you divide by mu, and you find that your form of the solution looks something like this. Well, it turns out in higher dimensions that something very, very similar happens. So we'll take our A here to be an n by n matrix, and we'll assume that B here is some column vector with n entries, which are all going to be continuous on I. Same for the entries of A, if it has functions of t as its entries. And then we'll say let x be a fundamental matrix for A. For this system, yeah, maybe it's better to say for the system. Okay. Then one particular solution the non-homogeneous is given by x times u, where u prime solves this system right here. So okay, so now this is, if you look at it, just like what we saw for variation of parameters before we started talking about systems. But let's just see, how do we get from this formula right here to a solution for xp? Well, we're going to need u by itself, so we would have to solve, and we could do that by multiplying both sides by x inverse if x inverse existed. Does x inverse exist? Yes. How do you know? Well, it's a fundamental matrix, so it forms a basis. That means its columns are linearly independent, so it's going to be an invertible matrix. Okay, great. So we can do that step. That's legitimate. And then we can integrate both sides. And I know it looks weird seeing a matrix inside an integral like that, but actually let me call that GT. But keep in mind, you integrate a matrix the same way that you differentiate it. Namely, you just integrate each entry individually, so that there's really nothing to it. And then our solution xp is supposed to be x times u. So then xp is going to be x times u, so that's going to be x times the integral of x inverse b dt. And so that is very similar to what we were looking at before. And there's a little bit more to that story. We'll come back to that in an upcoming video. But for now, that's our variation of parts formula. And we'll do an example in the next clip.